evening all. Good evening, ma'am. Hope you are all back after your vacation holidays, right?
Yes, ma'am.
How was your vacation?
Good, ma'am.
Good. Enjoyed?
Yes, ma'am.
Yes, okay. So now we are here. Do you know why we have assembled here?
Yes.
Just to discuss a case study on what is the topic? AC and DC characteristics of op-amp. So as we discussed in the class and in laboratory classes about op-amp, I think you have an idea about what is an op-amp. Op-amp is nothing but it is an operational amplifier. So why we are calling it as op-amp is since it is used to do all the mathematical functions like addition, subtraction, multiplication, division, like all mathematical, it is used to access all mathematical operations. So we used to call it as op-amp. And that op-amp is named as IC741. I think in your laboratory classes you have seen that IC. So in our next class we will just discuss about the entire internal circuit of that IC741. Okay. And so many advantages and applications in op-amp. And now we have gathered here to have a discussion on case study of AC and DC characteristics of op-amp. So first AC characteristics means we have four types like input bias current, input offset current, input offset voltage, then thermal drift. And same in DC characteristics we have two types, that is frequency response and slew rate. Just let us have a case study on these topics. Okay, are you all ready? Yes. Shall we start? Please get start. Yes, please.
So good morning, guys. Today we are going to discuss about the DC and AC characteristics. First, definitions of DC characteristics. DC characteristics is a described to
Actually, DC characteristics means the characteristics of an op-amp. Okay, characteristics of an op-amp. So we have the case study means we should entirely discuss about applications and its drawbacks and features, everything. Okay. So here we have types of DC characteristics, right? Like input offset current, input offset voltage, then thermal drift, and input bias current. So we are going to say about input types or anything types, right? Introduction about please proceed. DC characteristics and solely AC na ipdi DC na ipdi. Before doing a case study, we should know about what is AC characteristics and what is DC characteristics. Appin solli sollu.
So first we want to know about what is DC characteristics and what is AC characteristics. DC characteristics is described to input amplifier that measures the input amplifier when constant low frequency is applied. For example, DC voltage.
So types of AC and DC characteristics. First one is input offset voltage. So input offset voltage is a small differential DC voltage between input and output. So input is directly proportional and output is inversely proportional. So both are mediums and both of the operations are accurate. So next one is input current bias. So input current bias is having two terminals, one and terminals two, positives and negatives. So both are connected to the intermediate performs into the AC and DC characteristics.
This is about the input offset current.
So now we are going to discuss each type, right? First one is the bias current is over, and next one is
Input
offset current.
The input offset current that is the input bias current have the differences in the two input terminals, that is called as input offset current. Next is about CMOR, that is common mode rejection ratio. That is the ratio of integration to the common mode.
Next is PSR, which is power supply rejection ratio. The ability of PSR is to reject the fluctuations which is applied in the input voltage. So means using which is depends on the input voltage and the internal DC.
DC frequency.
So now let us know what is AC carrier. AC carrier which is also takes the part of increased amplitude when it is constantly changing like AC voltage.
Gain bandwidth GPP, and the product of an open amplifier doesn't close to the frequency, and it indicates that the signal is amplified through the command, and it has a lower gain with the higher frequency. Open loop gain. The amplifier is the amplifier indicates without any feedback, and the gain has been very high with a decrease in feedback.
Now let us see about SR, it's simple slave rate. So the maximum rate of the output voltage current which is easily and fastly responds to the input voltage. It is usually measured by V by mu s.
Slew rate. And other thing is frequency response.
This number frequency.
Next we are going to see about total harmonic restoration, THD. Restoration is introduced introduced at the output signal due to the non-linearities in the output amplifier. The lower restoration is desirable to the high fidelity